Good afternoon. I'm Deanna Evans, Executive Director for Startup UCLA. Thank you for joining us for UCLA's Faculty Innovation Fellows 2021 Pitch Showcase. The Faculty Innovation Fellows program was created in 2019 as a collaboration between Startup UCLA, the Technology Development Group, and the Office of Research and Creative Activities. Today's event is a celebration of the third cohort. We'll start off the event this afternoon with a welcome from Associate Vice Chancellor and President and CEO of the Technology Development Group at UCLA, Amir Nyberg.
Thank you, Deanna. Let me just start by thanking you and the entire Startup UCLA team. Your hard work and efforts through this past few months created the pitches that we're going to see today. And we're all really excited to see the change and transformations the team went through in your program. I'd also like to thank our colleagues in ORCA and obviously in TDG. It takes a village to build a new venture or a new activity. And this program, Faculty Innovation Fellows, is aimed and designed to be the stepping stone, the first step in building a new activity. It may be a for-profit startup company, as well as non-profit centers and other activities within UCLA. We identified this gap 3 years ago, that we have amazing science on campus, amazing creative activities, but sometimes lack the discipline that is required to get a new business up and running. And so the Faculty Innovation Fellows was aimed and designed to bridge that gap. We're also closing another gap with this program between South Campus and Northern Campus, as we reach out to multidisciplinary teams throughout campus to create new and exciting programs. I hope that this year's Faculty Innovation Fellows will serve as ambassadors for this program and will help us recruit new teams for next year's class. Lastly, as you can see from my background, I would like to invite everyone to join us next week to LA Best, the premier event for life science in LA County. Thank you very much, Diana, and I'm looking forward to the program.
Thank you, Amir. Thank you for joining us. Next, we'll hear from Todd Presner, Ross Professor of the Department of European Languages and Transcultural Studies, and advisor to the Vice Chancellor for Research and Creative Activities.
Great, thank you, Deanna. And thank you, Amir, as well, for your support. I send regards from Vice Chancellor Roger Wakamoto, who cannot be here today, but is a big supporter and proponent of this program. I should say a couple words about the Faculty Innovation Fellows Program, because it's really a unique opportunity at UCLA for what is truly a North-South collaboration. We've had faculty who have participated in the program from the arts, the humanities, the social sciences, as well as engineering, physical sciences, and medicine. All the faculty are interested in entrepreneurship, and all the faculty are interested in opportunities for applications and translational research. We wouldn't be able to do this without a true collaboration between the Startup UCLA, the Technology Development Group, and ORCA, the Office of Research and Creative Activities. I specifically want to call out and thank Deanna Evans, the Executive Director, Robert Jadon, Glenn Tres-Thornton, Jaime Balboa, and faculty advisor Tim Groling of Startup UCLA. Their leadership and support has been instrumental for getting this program and sustaining this program throughout the last 3 years. I also want to thank Amir Nyberg, Joel Kale, Diana Lizovsky, and finally, Mary Aquino and Roger Wakamoto from the Office of Research and Creative Activities. A couple words about entrepreneurship before we get going. We're interested. This program actually was started through a conversation that Roger Wakamoto had with a number of campus leaders, asking what can we do to better support entrepreneurship across the entire campus. Of course, many pockets of innovation have been underway for years, but the idea is, what could we do holistically? What could we do for the campus as a whole? And what would be the value of bringing people together from diverse parts of the campus? If you had someone from the arts and the humanities talking to someone from medicine, talking to someone from economics, talking to someone from engineering, all of whom had many of the same kind of questions about how to realize their ideas, how to build a business, right? How to develop a pitch. how to do concept development, how to raise funds, how to bring great ideas to market, right? These are all things that are shared in common, regardless of what discipline one's coming from. And not only that, all faculty are on kind of a common journey here as they think about either commercializing their research, bringing their research to a greater public, developing an institute, driving social change, right? Because entrepreneurship can mean many things to many people. On one hand, it may mean business development, but may also mean driving social change. And those two things may come together in many creative ways. When Vice Chancellor Wakamoto renamed the Office of Research and Creative Activities, he was recognizing the fact that research is driven by creative activities and that creative activities require research. Both of these things have tremendous public application, public impact, and it's truly about the ideas of applications and translation that I think was motivating this program. So with that, we're really excited to begin to hear the pitches from the third cohort of the Faculty Innovation Fellows. I want to thank everybody who's participated in this program, and we're really excited that we're able to continue it and collaborate with Startup UCLA. Thank you so much, Diana.
Thank you, Todd. Truly appreciate those remarks. And you know, I in turn have to thank both TDG and the Vice Chancellor for Research and Creative Activities for this partnership. You know, this collaboration between our three programs has been such a great opportunity to cultivate and amplify faculty entrepreneurship at UCLA. And I hope these 9 projects inspire you to look at research coming out of UCLA through an entrepreneurial lens to see the great impact and value that it has for Los Angeles and beyond. And in addition, I could not have done any of this without the Startup UCLA team for the workshops, the venture consulting meetings, and the thought put into creating a valuable experience for the fellows this year. Thank you, Robert, Tim, and Glenn Trez, for your time and your energy. And thank you to Startup UCLA's great legal sponsor, Fenwick, who hosted a legal workshop and legal office hours for the fellows. A special thank you to Faisal Rashid of Fenwick. So now we are at the time where we're all here for so let's begin our program with our first presenter. Scott Camulotta is an associate professor in psychiatry and biobehavioral sciences. Please go ahead, Scott.
There we go. I think you can all hear me. Well, thanks so much, Deanna. It's just fantastic to be here today. My name is Scott. You know, I've been a faculty member here at UCLA for quite a few years now. I lead a research center, but my favorite role and the reason why I'm here with all of you today is I'm a parent. 2 years ago, my daughter Sophie had surgery. She recovered, but what I still remember is just how afraid she was before her surgery. And it turns out this is a really common theme in kids. There's a lot of fear of the unknown and anxiety before surgery. Hospitals recognize this. That's why they have storybooks. They encourage medical play. And now there are even 360-degree virtual tours that take place on a flat computer screen. But none of these tools really acclimate children to what's going to happen on the day of surgery. It leaves a lot of unanswered questions. Where will I be? Kids don't usually see the operating room until the day of when they're wheeled in on a gurney. All of a sudden, there's a lot of people standing over them, asking them questions, poking and prodding, wearing seemingly strange costumes. Kids are wondering if they're going to wake up during the surgery. And many other questions. These are just a few of the top questions kids have. There's a cost to all these unanswered questions. We know that scared kids require more staff time, sometimes multiple nurses just to hold down a child. Versed, other anti-anxiety medications. We know that anxiety leads to more complications, bad outcomes, longer hospital stays. Just a lose-lose situation for everyone, certainly for the kids, for their parents or guardians, and the hospitals. Our solution, as shown in this demo, is a virtual reality walkthrough or experience that can better acclimate the kids to what's going to happen the day of surgery. They'll get to choose a guide, a unicorn shown in this picture, one of my daughter's personal favorites. They will get to interact with their environment, shown here a feeling thermometer that will give feedback to the surgical team to better prepare for how the child is going to respond the day of surgery. The child will get to move through the walkthrough, starting in the pre-op area, going to the hallway, ending up in the operating room, and virtually waking up in the recovery area. You know, the current tools that are out there, folks, they just don't cut it. They are representations of the real thing, but they don't feel like the real thing. There's a reason why VR immersion therapy is effective, because it's the only way to really acclimate. And another consideration is things like medical play. They take a lot of time with somebody role playing with the child. The reality is it often doesn't happen until the day of surgery, when the kids are already agitated and just less able to acclimate. VR goggles could be sent home with the child, and the experience could take place during pre-care visits. When we look at what's out there, VR companies are starting to emerge, but we haven't found any that really strikes that balance to both acclimate and offer a degree of gamification to ease the child into the experience. If we look at Doc McStuffins, it certainly has some education to it. It appeals to the younger age group, but it's third person. Doesn't really acclimate, very cartoonish. On the other end of the spectrum, you've got VR guided tours that again are third person. They don't really engage the child. So we want to strike that right balance. You know, this is the right time. The VR healthcare market is exploding, projected to reach 2.4 billion by 2026, about 40% of the market in North America. We've got the right team. Myself, Scott Camulotta, I have a background in statistics. I've been helping to evaluate and develop digital health interventions for many years now. My co-founder, Justin Wagner, a pediatric surgeon here at Mattel Children's Hospital. He's also a parent, very passionate about helping kids. A team of advisors, Nanthia Sutana, she led the development of the VR demo that you saw. She's a world-class neuroscientist, has her own VR lab, also a parent. We're getting great software sales and marketing expertise from Alice Park, who works for Oracle. And I can't forget Megan and Tracy, our child life specialists, who are giving invaluable input on the design itself, so it has real appeal for kids. Right now, we are looking for early stage investors and partners who are as passionate about helping kids as we are. My contact information is on here, and won't you join us? Thank you so much for your time.
Thank you, Scott. That was great.
Let me see if I find the stop share here. Oh, there we go. Okay.
Our next presenter is Liang Gao, Assistant Professor of Bioengineering.
Hi everyone, my name is Liang Gao. Today I will introduce our revolutionary high-resolution real-time flash imaging LiDAR systems. I want to start my pitch from these tragic stories recently happened in Arizona. A Uber self-driving car hit and killed pedestrians on a city road. And this story quickly became the head news of many news outlets. And Uber had been widely criticized for the rush move in autonomous driving. One of the key factors for this accident is a spinning LiDAR on this car failed to recognize the pedestrian. We cannot afford such a tragedy to happen again. And there is unmet need to develop advanced imaging LiDAR systems to push the safety of autonomous driving to the next level. Beyond autonomous driving, LiDARs also have numerous applications in other fields, such as robotics and remote sensing. In the US market alone, the market size has reached 1.1 billion in the year 2020, and this number is expected to grow to $2.8 billion in the year 2025. There are two types of the LiDAR systems currently deployed on self-driving cars. The first type is called spinning LiDAR. Spinning LiDAR scans laser beam in the circumferential manners and measure the time-of-flight signals or reflect signals. But the drawback is that it only has very few lines along the vertical resolutions, along the vertical directions, resulting in a very low vertical resolution. So this type of LiDAR cannot be used to recognize the different targets. For example, we cannot tell apart our pedestrians from large animals. By contrast, imaging LiDAR can provide much higher resolution. By using these scanning mirrors to perform this two-dimensional raster scan. But to acquire high resolution like this one is very time consuming, so it cannot be applied for this real-time autonomous drivings, where timing is critically important for this decision making. To address this problem, our solution is to acquire these 3D scenes by a single snapshot. This is different from these conventional 1.0 technologies, which rely on scanning. Our technology, which we call 2.0 tech, is based on this published work, light field tomography, which is built upon these computational imaging architectures. A key feature of this 2.0 tech is that we can acquire these three-dimensional scenes by a single snapshot without using any scanning mechanisms. This is real-time flash imaging LiDAR demo using our system. We image these dynamic scenes in our lab. You can see when we rotate this middle ladder at high speed, our camera can recover these 3D motions with very high fidelities. I want to emphasize such a video cannot be recorded using conventional 1.0 scanning-based LiDARs, because otherwise it will introduce severe motion artifacts. Compared with scanning-based systems, our 2.0 tech offers several few key advantages. For example, it's the first LiDAR system can provide this HD resolution at 30 frames per second, and also has 0 moving parts, so it's super durable. And for mass production, we expect the cost of the whole system will be less than $200. Although our imaging LiDAR system can be applied for many different applications, our niche effort will be focused on autonomous driving. Our business model is to partner with a major car manufacturer and develop these customer HD imaging LiDAR systems for the self-driving cars. There are several major players in this field, but you can say all their LiDAR technology are based on this scanning-based 1.0 tech, and they have provided very limited vertical resolution and field of view. By contrast, our technology is the only technology that's based on the 2.0 snapshot acquisition and provide unprecedented vertical resolutions and field of view. Regarding timeline, we already have research prototype running in the lab, and currently we are building an engineering prototype and expect to finish it by the end of the summer. And we expect to have MVP by the end of this year. I'm the founder of these companies. I have over 15 years experience in developing optical imaging hardwares as well as LiDAR systems. Currently, we are looking for $1 million seed grant for developing the MVP. We are also looking for advisors to join our team, and we are also open to the collaborations and partnerships. Okay, everyone, who want to be a partner with us and build the next generation imaging LiDAR systems to push the safety of autonomous driving to the next level? Thanks again for your patience. And if you have any questions, I can be reached at this email. Thanks.
Thank you, Leon. And now our next presenter is Sierra Burkhardt, Academic Director of UCLA Geospatial.
Thank you, Deanna, and thank you all so much for taking the time to be here today. I am excited to be here to share some latest developments that will revolutionize the process of political districting. The process of political districting happens every 10 years in the United States, in addition to times when there might be situations where jurisdictions are required by courts to redistrict. When we fill out that census form every 10 years, we are not only influencing where federal dollars go, but we are also deciding how we will draw the lines for our next 10 years of our political system. I'm looking here at a map of the congressional districts in California, Southern California, and every 10 years, these lines will shift. But districting is much more than redrawing the lines of congressional districts and redrawing the lines of legislative districts around the country. Districting happens at the local level as well, within about 87,000 municipalities around the United States, as well as tens of thousands of school districts and special districts. So this is not just a small problem or a small thing to deal with that happens on one-off occasions at the level of states and larger geographic entities. Districting is local and districting is everywhere. It is also a complicated and time-intensive process that requires specialized knowledge of geographic information system software, as well as the legal requirements that are in place for districting. At least it used to be that way until myself, along with a colleague at Geographio, developed a web-based electoral districting platform that contains street block level population data for the entirety of the United States. Now, districting is as simple as what you see here. Clicking on street blocks, allocating them to districts, and watching the demographics of your districts evolve in front of you. This tool is so simple that it can be used to teach districting to students, as it is right now being used by the UCLA Voting Rights Project. And it's also powerful enough to empower policymakers who know their communities to make decisions responsibly and without the need to involve consultants and other outside firms that charge a lot for this service. Our platform has several key advantages over the existing procedures that are used for drawing districts. Again, the complex technical knowledge that is required traditionally for the districting process is erased and becomes as simple as using a browser-based tool. It is actually easier to draw districts with the Geographio tool than it is to draw a little smiley face with Microsoft Paint. It's a very simple process, and the key point here is that your demographics for your districts are calculated on the fly, and you can make iterative decisions without having to go back to your consultants many times. Furthermore, in a process that is typically very time-intensive even for professionals, we have preloaded this platform with all needed demographic data covering the entire United States. This is useful not just for policymakers in that case, but also for consultancies who are interested in increasing their volume and being able to reach more customers for the districting process. Essentially, the districting process that was opaque, complex, and time-intensive has now become quick and intuitive, empowering more people to understand and be involved in the districting process. Districting happens only once every 10 years nationwide, but when that does happen, we are looking at a conservatively estimated $1 billion market. This rush to draw districts around the country happens at the larger geographic scales as well as at the very local level. And our firm, Geographio, believes that we are very well positioned to reach approximately a $50 million market here in the state of California. We are looking to partner both with consultancies that already do districting work serving these entities, as well as going directly to those entities and allowing policymakers, again, to be empowered directly to make their own decisions about districting. We have the right team to make this happen as well. I am the lead developer and engineer. I have research interests in political and electoral geography, but my professional background of being a founding partner of a former leading geospatial tech startup in Mexico, as well as my years of experience with this kind of work, have led me to already develop a very successful prototype that is being used in industry. And my colleague, Michael Shin, has expertise in electoral geography and districting, as well as management consulting experience. We are looking for early stage seed investors. We have a product that is usable and being used, but we want to be able to increase our reach and make our tool front and center in the districting process in this coming year. Thank you all for your time.
Thank you, Sierra. Our next presenter is Amit Hasani, project scientist in dentistry and bioengineering.
Hello, everyone. I'm Mahdi from UCLA Bioengineering. Have you ever experienced bleeding gums when you floss? Well, you may have early gum disease. Gum disease or periodontitis is a common chronic destructive inflammatory disease. If left untreated, it will damage the tooth supporting tissue and bones, and eventually leads to tooth loss, which would significantly impact patients' quality of life. The current standard of cares are quite expensive and insufficient, but no worries, we have a solution. We developed the first-in-class periodontal patch. It's an innovation based on macroarray to address local tissue retention and prolonged drug release. As you can see, our patch can be applied to the infected areas by patient or dental professionals. The support layer is designed to be dissolvable in less than 5 minutes, and the drug-loaded tip will stay in the gum tissue for a prolonged release over a course of weeks. This macroarray patch is easy to administer and painless, thus improving patient quality of life. So we are providing local delivery and prolonged release at the same time. These needles would sustainably deliver therapeutic for inhibiting the bacterial growth while modulating immune cell function. This is the first ever periodontal patch that can actually reverse the disease, because our active ingredients not only fight bacteria, but also regenerate damaged and lost tissues. I also need to mention that the polymers that are being used in our platform are all available in GMP grade and have been approved by FDA for various medical applications. We have performed proof of concept experiments in a small and large preclinical animal models to test safety and effectiveness of our patch. As you can see in the CT scan images here, only 8 weeks post-insertion, animal treated with our therapeutic patch can regain their lost periodontal bone. This patent-pending technology belongs to UCLA. This macroarray drug delivery patch is highly versatile technological platform that could have wide application for treating diseases in the oral cavity. Not hard to see from this table, comparing to current treatments, or patch which is developed at UCLA is quite unique and can offer dual delivery of antibiotics as well as immunomodulatory molecules, as well as providing sustained release and local retention. We are addressing over a $2.5 billion market in periodontal market. And we think that we can capture over $80 million as our serviceable obtainable market just in the United States only 4 years after incorporation. Our business strategy is to first advertise macroneedle patch directly to customers by providing easily available clinical and preclinical research data. For first use, a patient will learn how to place the patch at dental offices, and then they can purchase them from pharmacies for about $20 per patch. Currently, we are seeking about $1 million preceding fund, which will get us through pre-IND meeting with FDA. With this fund, we will optimize our formulation and we will perform large-scale preclinical animal studies. We will also tailor the fabrication process based on GMP standards. We are a team of experienced bioengineers who provide efficient, effective, and affordable dental solutions. Our patch can be manufactured at scale with low cost. There is a current market demand for our product with dental hygienists. Our ultimate goal is to sell it over the counter as a point of care to be affordable for all patients. Please join us and help us to save one tooth at a time. Thank you very much.
Thank you, Madi. Our next presenter is Ming Gul, Professor of Neurology.
Hello, my name is Ming Gul. I am a neurologist and a scientist seeing patients and running a lab researching on aging and neurodegenerative diseases. I also direct an anti-aging center at UCLA. As a 2021 Faculty Innovation Fellow at UCLA, I'm very excited to pitch our work on mito rejuvenation, the goal of which is to reverse aging to delay diseases. As a physician, I'm acutely aware of a problem in the medical field that a group of diseases known as diseases of aging account for almost 70% of death in the US. These include heart disease, cancer, stroke, Alzheimer's disease, and diabetes. Aging is the strongest risk factor for each of these diseases. Take Alzheimer's disease, for example. Numerous studies suggest that up to 50% of us over the age of 85 may get the disease. The prevalence of Alzheimer's disease doubles every 5 years. Therefore, if we can stop aging by 5 years, our society will cut the disease burden by half. Our goal is to pull down the aging curve to cut the incidence of neurodegenerative diseases, heart disease, cancer, diabetes, frailty, and infections due to compromised immune systems. A key site at which cellular aging occurs is the mitochondria, the powerhouse of the cell. They contain their own DNA, and the accumulation of damaged DNA leads to cellular dysfunction and aging, and ultimately cellular dysfunction and death, and ultimately aging. This damaged DNA leads to pathology in the muscle, the brain, the heart, and the pancreas. What we aim to do is to remove damaged mitochondrial DNA in multiple tissues to reverse aging. We have generated proof of principle in a model organism to show that we can remove up to 95% of damaged mtDNA by manipulating existing pathways that we already have in our body, as well as identifying new compound. Our next step is to carry out similar genetic and compound screens in human cells to bring this work to clinic. Our team is comprised of me as a neurologist and pharmacologist and director of the Anti-Aging Center. Bruce Hay is a key collaborator at Caltech, and Robert Demiselle directs the molecular screening facilities at UCLA. The market in this space is enormous. Just considering Alzheimer's disease alone, it is at least $2.2 billion with an annual projected growth of almost 20%. Regarding competition in the field, the 4 top anti-aging medicine startups are listed here. They focus on telomerase, immunosenescence, senescent cells, and tissue regeneration. Our other bigger companies include Calico and Juvenescence are also actively working on aging. However, to our knowledge, our strategy for mtDNA-based reversal of aging is unique. Regarding Milestone, our ongoing work utilizes a model organism to screen for genes and compounds that promote removal of mitochondrial DNA damage. Our next step is to transition this effort to human cells. We will carry out several genetic and compound screens, validate the hits in vivo functional systems, and ultimately seek IP protection. In parallel with this specific project, as director of the only NIH-funded UCLA Aging Center, I strive more generally to promote collaborations and innovations among faculty, postdoc, and students to develop other anti-aging therapies. So stay tuned.
Thank you, Ming, for your mito rejuvenation project. Our next presenter is Justin Karlin, Assistant Professor of the Stein and Doheny Eye Institutes.
Hello, this is Justin Karlin. I'm on the faculty at the Doheny and Stein Eye Institutes at UCLA. And I'm here today to tell you about an exciting new product we're developing. It's a device and process to make serum tears more quickly and more safely. So what are serum tears? They're eye drops that are made from a patient's own blood. Following phlebotomy, the blood is centrifuged to separate the serum from the red blood cells. This serum is removed, diluted, and aliquoted into eyedropper bottles, which then can be applied topical to the ophthalmic surface. Serum tears treat a wide variety of diseases, including common ones like dry eye syndrome, and uncommon diseases such as Stevens-Johnson syndrome, neurotrophic keratopathy, and persistent epithelial defect, to name a few. How do they work? Serum tears contain growth factors that promote healing. They contain salts and are pH balanced, so they're gentle on the eye, and they contain proteins such as antibodies, which have antimicrobial action. Searching PubMed for serum tears and related terms reveals that in the last 20 years, there's been an increase in the number of publications on serum tears. Serum tears have been examined and investigated for a variety of conditions, including dry eye, graft versus host disease, and so forth. So what's the problem? Serum tears are expensive, both in the time required to produce them and in the monetary cost. The process of producing serum tears starts with consultation with an ophthalmologist. This is followed by phlebotomy. The blood is transferred to a laboratory where the blood is centrifuged, serum isolated, and then under sterile conditions, the serum is aliquoted and diluted into eyedropper bottles. Of course, this laboratory preparation step is the most expensive and time-consuming of the steps. Only then can the patient begin therapy, and of course, throughout the process, quality control must take place to ensure that the serum tears are not contaminated. I've done market research here, looking into how much serum tears cost in dollar terms, both around the country and across the globe. And this chart demonstrates various prices of a 4-month supply of serum tears at various laboratories and other producers. And what this chart shows is that, first, the price is inconsistent, and 2, that the price can get quite expensive. So what's the solution? It's a low-cost, fast, and safe way to make serum tears. It's the serum tube. The serum tube circumvents the laboratory and aliquoting steps and goes straight from phlebotomy to therapy with intrinsic quality control. The prototype shown here begins with a cylinder that contains a glass microfiber filter and 2 gaskets providing a watertight seal. That's capped with a standard venipuncture membrane cap, coupled to a funnel, 3-way stopcock, and our specialized secondary coupling mechanism, which connects this filtration apparatus directly to a standard eyedropper bottle. There's the assembled device on the right. In addition to prototype design, we've also refined the process of diluting and filtering the serum tears in a single step. We've forged a strategic partnership with a filter producing company, and we've initiated preclinical studies to ensure the quality of the serum tears produced by our method is equivalent to that produced by standard methods. We're in the process of initiating clinical testing and securing intellectual property. We're looking for manufacturing expertise to help us produce this device more safely and more cost effectively. And of course, we're looking for marketing expertise so that we can go directly to doctors and patients and inform them about this revolutionary new device. You can contact me at my website, serum.tube, or at the email addresses listed below.
Thank you, Justin. Our next presenter is Roy Wolman. He's a professor of chemistry and biochemistry.
Excellent, and thank you very much, everyone, for showing up and for this wonderful opportunity to present our work. So I'm going to talk about our nascent effort to start a new company called Biocartography, with its mission is really to mapping biology for the betterment of human health. So think of the situation, right? You go talk to your doctor about a lump, and they suggest that you do a biopsy, which is a very common procedure. Yikes! Ooh, it doesn't look very good. The next step is a really crazy step, right? They take your biopsy sample and stain it basically with parts of tree barks, right? So the dyes invented in end of the 19th century. And then based on those staining with those really old dyes, a pathologist will then diagnose and make a decision of what to do with, is it a biopsy, is it tumorigenic, etc. So this is really what it looks like, right? This is this pinkish color that typical histology section are looking. And really with the pathology market getting to close to $1 billion, so this is figures from a few years ago, right? It's still very much of a growing market. All that market is really based on basically on tree bark, right? On this very old staining technology. So our mission is to really provide mapping tools for biomedical sample and research diagnostics. So if we think of this H&E staining, right, this current state-of-the-art staining of samples, we think of them as one piece of information that the pathologist could use. But in reality, right, maps have many more layers of information, and we can extract much more information to help guide better diagnostics of disease conditions. So what are we going to do? How are we going to do that, right? What's our secret sauce? So our approach is to try to maximize information content during staining itself. So first, we take our pathologist and replace it with a computer. But then we ask the computer a very interesting question. We ask the computer, if you could take the sample and stain it and measure up to 92,000 different molecules or specific type of mRNA molecule and different combination, what experiments will be the most informative, right? What type of measurement will maximize the information content in that sample? And right, based on that optimal experimental design, right, we can then perform our experiment and generate multiple measurements, right? They're all complementary to each other. They're all providing different aspects of information about the sample. And then our dear computer will take those different samples and through a machine learning procedure, will really be able to generate much richer and much more informative maps of what's really happening inside the biology. Now, it's not as accurate as it could be otherwise, but with only 24 measurements, we can get really good accuracy in terms of identifying the true molecular state of different cells in that sample. So what makes biocartography unique compared to other approaches to do this mapping of biological specimens? So there's probably the biggest company in this space, 10x Genomics, is based on the idea that we count the different RNA molecules in the sample through sequencing based on the fact that each one of those RNA is barcoded spatially with this different specimen. So it only works in 2D sections and requires roughly 10,000 reads per spot. So if you think of a sample that has 1 billion reads, like in the mouse brain, our favorite organ, right, that will cost $10 million to look at one organ, right? Not very scalable. Similar other approaches out there, a company called VizGen, also count RNA for imaging-based approaches. So it scales better, it's cheaper, but on the other hand, it does take 2 days for a single 2D section. So again, doing a whole mouse brain will take roughly 3 years. Again, not very realistic. So our approach to say, we can do 3D volumetric measuring, and really the concept is that we're measuring good enough, right? Our accuracy is not 100%, but because we optimize our experiments to recover that information with less number of measurements, we can get up to 90% accuracy, be good enough, and be much faster and much cheaper. So where we are now, currently, we're what I think of as phase 0 traction. We're still in the process of proof of principle of our technology, with the idea that there are 2 markets that we're really hoping to expand to. In the long immediate market will be the research market. So take what we're now doing and just sell it to other people in terms of kits and instruments. And in the longer term, there is the whole big diagnostic market that we think our types of map will be really informative to make much more accurate diagnostic of different types of biopsies. And we're now always looking for partnerships, the right partnerships to help us transition from our current proof of principle to actually a working company. And with that, I'll thank you for your time. And if anyone has any comments, here is sort of my information here, the website and my email. Thank you very much.
Thank you, Roy. Our next presenter is Mona Jarrahi, Professor of Electrical and Computer Engineering.
Okay, good evening, everyone. My name is Mona Jarrahi. I'm a co-founder of Lookin. In the next 5 minutes, I explain to you how our technology is going to reduce the scrap rate in battery electrode manufacturing, reduce the potential for safety hazard, and save money. So here is a typical manufacturing process for lithium-ion batteries. A metal foil is coated with a slurry, then it goes through drying and calendering processes, is cut into electrode pieces, which are assembled, filled with an electrolyte to form the full battery cell. There are many defects that can be introduced in this manufacturing process, which unfortunately will go unnoticed because of the lack of any practical quality control system that can be embedded in line. What is really done is that electrical testing is performed on the end product, which typically shows a scrap rate of 5 to 10%, which does not even include those defective batteries that pass electrical tests, are delivered to the customer, and later show degraded performance, and most importantly, safety hazard. I'm pretty sure you have all heard about fire and explosions involving lithium-ion batteries used in cars, electronics, energy storage centers, e-cigarettes, and airplanes. Apart from this safety hazard, there is also a major financial loss for manufacturers, considering this 5 to 10% scrap rate, which one can see from the huge size of the lithium-ion battery market, which only in 2019 generated $48 billion revenue and is projected to reach $132 billion by 2015, driven by the growing demand in electric vehicles as well as energy storage solutions. Additionally, major market players like LG Chem and Tesla announced setting up gigafactories during this prediction period, which is projected to increase their market size even further. To address this unmet need for quality control tools, battery manufacturers have looked into various X-ray, infrared, and ultrasound imaging techniques, which, as you can see from this table, all have a combination of limitations regarding their field of view, scanning speed, and health hazard. However, Lookin uses terahertz scanning to address this quality control need, which, as I will explain shortly, does not have any of these limitations. Our scanners send a terahertz pulse to the battery electrode. Some part of the pulse gets reflected from the top surface. Some of it gets reflected from the interface between metal and the coating. And by measuring the timing and intensity of these pulses, one can measure coating thicknesses and find potential defects, which change the intensity of the pulses or vary their timing. A major enabler factor in our scanners is the terahertz source detector technology that we use, which was developed in my lab over the past 10 years, that uses special photoconductors with embedded nanostructures to offer 1,000 times higher sensitivities and faster scanning speeds compared to the state of the art. This technology has already received more than $12 million research funding over the past 10 years that allowed us to mature this technology, which has also received many recognitions and awards, including recently, it was winner of LG Chem Battery Challenge. Here is a schematic of our scanner system. And on the right side, you can see images of the first scanner prototype that Lookin developed in our lab space. We have established partnerships with 2 Department of Energy national labs, NREL and Oak Ridge, and also major battery manufacturing companies like LG Chem, Navitas, and Imprint Energy. And in collaboration with them, we have done some initial proof of concept studies. We have received battery electrode samples from them, and by scanning them with our scanner, we proved that our scanners have the resolution and sensitivity that is sufficient to detect all those defects that impact battery performance. Here, for example, are some top view and cross-sectional views of defective battery electrodes with agglomerate and divots. As you can see, while visually you have to use very strong flashlight to vaguely see some abnormality, terahertz images show a lot of details, not only about defects, but also how they impact the coating thickness variations, which are very important in battery quality control. Here is our development timeline. Our company was funded in 2019 by myself and one of my former graduate students, Nezi Yardimci, who is the CEO of the company. In early 2020, our first generation prototype was ready, and with collaboration with our industrial partners, we have finished the first feasibility studies, which was completed by mid-2020. We are now working on a second generation scanner that is specifically built to be installed in roll-to-roll manufacturing plants, and we expect that scanner to be ready by end of 21. And we have plans to do validation studies on site using this scanner, which we expect to be done by mid-2020. And by then, our scanner should be ready for customers. Around that time, we are planning to start Series 8 fundraising to expand our product development, sales, and marketing. So far, we have received $3.4 million non-dilutive funding from federal agencies through small business grants. But we are interested in expanding our collaborations and partnerships, especially with battery industry and funding agencies and investors. If you want to learn more about our company and you're interested in partnerships, please contact us with the email that I provide here. Thank you very much.
Thank you very much, Mona. Our last team presenting this afternoon is Ian Holloway, Associate Professor in Social Welfare, and Alex Garner, past Senior Health Innovation Strategist at Hornet.
Thank you, Deanna, and good afternoon. We're delighted to have the opportunity to present the Gay Sexuality and Social Policy Initiative at UCLA Luskin. I'm Ian Holloway, Associate Professor of Social Welfare and the Faculty Director of GSSPI.
Hi, I'm Alex Garner. I was the Senior Health Innovation Strategist at Hornet. Hornet is a gay social networking app with over 25 million users, and I manage all of our health-related content, programs, and research, and I'm the Deputy Director of GSSPI. Over 70 countries around the world criminalize homosexuality. This means that in these countries, gay men can face persecution, imprisonment, torture, and sometimes death just for the crime of having gay sex. To put that in context, gay sex was decriminalized in the US in 2003. That's less than 20 years ago. And criminalization is but one of many intersecting issues gay men face around our sex. Globally, gay sex continues to be devalued and stigmatized. Research on gay sex and sexuality is limited, leaving little evidence to change policy, shift culture, or foster community engagement. Gay sex is valuable, an integral part of the gay male experience, and can inform all people's relationship to sexuality. Yet not one academic institution centers the understanding of gay sex and sexuality until now.
We're enthusiastic to address this problem through the Gay Sexuality and Social Policy Initiative at UCLA Luskin, an academic center dedicated to empowering global gay communities. We're confident that this work will have a profound impact on the quality of life of gay men around the world and offer important insights around sexuality for all.
Our strategic objectives span the academy and diverse gay communities across the globe. GSSPI conducts high-impact research on gay male sex and sexuality, educates researchers and policymakers to embrace gay male sexuality, advances discourse about the complex experiences of gay men, empowers global gay communities, and through pre-doctoral and postdoctoral fellowships, cultivates the next generation of gay sexuality scholars.
To support GSSPI, we will seek traditional opportunities for funding academic initiatives. These include grants through the National Institutes of Health and other institutions, foundation funding from Arcus, Open Society, and Templeton Foundation, and private donations from vanguards of entertainment and technology. In addition, we will pursue innovative funding opportunities through grassroots engagement with diverse global gay communities.
Gay social networking apps occupy a unique place in gay men's lives and are an important source of community and connection. These apps have proliferated for the past 10 years and are a prime opportunity for marketing and engagement, as well as content creation and advancing the research and community empowerment initiatives of GSSPI. Conventional marketing endeavors will also be utilized, such as websites, traditional media, and academic and community salons to highlight our groundbreaking research.
There is a dearth of competition in this space, but institutions that do exist have earned respect in the field. These include the Kinsey Institute at Indiana University, Pacific Center for Sex and Society at the University of Hawaii, and the Australian Research Center in Sex, Health, and Society at La Trobe University. All pursue research into human sexuality, but none of them center their efforts around gay sex and sexuality, as GSSPI will do.
GSSPI is a groundbreaking initiative that is by and for gay men. Our unique perspectives and lived experiences set us apart and will be key assets as we strive to better understand gay men's sex and sexuality. Sex is a topic that spans all parts of the human experience, and interdisciplinary collaborations will be critical for achieving our goals. A home at UCLA, the #1 public university in the world, will be essential to our success.
Between the two of us, we bring over 25 years of experience working closely to better understand and address the health needs of diverse gay communities. My background has been in clinical practice and academic research, while Alex is an expert in gay men's use of technology and utilizing that technology for education and research. Since 2018, Alex and I have collaborated on several research projects. We've presented our work on gay men's health at international conferences and published that work in academic journals. Here are some important milestones regarding the formalization of GSSPI. In mid-October, we were approved as a formal initiative by Gary Segura, the Dean of the Luskin School. In January, we received support from the UCLA Faculty Innovation Fellows Program. Earlier this spring, we redesigned the beta version of the GSSPI website, which we are currently programming. And this June, we will hold our first fundraising event in honor of Gay Pride Month.
There are many ways for you to get involved in the cutting edge work of GSSPI. Please visit our website, gaysexresearch.com, to subscribe to our mailing list and consider making a donation to support our mission.
Thank you again for the opportunity to pitch to you this afternoon. We hope you will join us on this groundbreaking journey to invest in the lives and sexuality of gay men. Deanna, you're muted.
Thanks. Thank you, Ian and Alex, for being our last presenter today. And thank you to all the fellows for your level of commitment to your projects, for the pitches this afternoon. We know that you put in a lot of time since January, attending workshops, attending venture consulting meetings, and really being thoughtful about how you want to proceed with your projects, whether it's a for-profit business, nonprofit, or even an institute, or just a product. So thank you again for your, your commitment to the Faculty Innovation Fellows program this year. And thank you to our audience for your time today to learn about the Faculty Innovation Fellows projects and the innovation that's being driven by UCLA faculty research. The event has been recorded and it will be shared on our social media channels. And we hope very much that in 2022 that we will have an in-person Faculty Innovation Fellows Pitch Showcase. I hope you are well and have an enjoyable evening. Thank you. Take care.